Today we're going to talk about geometric mean and its application as far as similar right triangles go. So the geometric mean, you've probably heard of mean, like mean, median, and mode. It has to do with finding the middle number, the number in the middle. That's called an arithmetic mean. There's also called a geometric mean. So the arithmetic mean is that you add the two numbers together and divide by 2. The geometric mean is that you multiply them together and you take the square root. So it would look like this. A over B, or excuse me, not A over B, A over X, so some number over the geometric mean is equal to the geometric mean over another number on either end. So if I ask you to find the geometric mean between a pair of numbers, this is how you would do it. So you would cross multiply, and you would get that X times X is X squared, and then A times B is A times B. To find out what X is, you would take the square root of both sides, and so X is equal to the square root of A times B. Most important today with us for what we need this for is how to solve a problem when you have an X squared. That's going to be our biggest concern. So if you look at 1, 2, and 3, what we have is, if I want to find the geometric mean between these, if I want the arithmetic mean, 9 plus 4 divided by 2 is 6.5. Okay, so the arithmetic mean, something you're familiar with, is 6.5. The geometric mean is 9 over X is equal to X over 4. When you cross multiply that, you get X squared is equal to 36, or X is equal to 6. So you can see that the numbers are a little bit different. It depends on the weighted. Geometric mean is most useful. It's useful in financing. It's useful in some engineering studies, and it is especially useful when you're dealing with numbers that vary greatly from really small to really big. It takes into account the weight of the numbers. Okay, number 2, the geometric mean of 14 and 6 would be 14 over X is equal to X over 6. 14 times 6 is 84, so X squared is equal to 84. And then we want to leave our answer in exact simplified radical form. So when we take the square root of both sides, the biggest perfect square that goes into 84 is 4. So that would be the square root of 4 and the square root of 21. I know what the square root of 4 is. It's 2. The square root of 21 is a decimal, so we're going to leave it inside the square root. Now, 2 root 21, or the square root of 84, is 9.16. Okay, so the approximate number would be 9.16, where the average, the mean, the arithmetic mean of these two numbers is 10. So again, they're close, but not exactly the same. And then lastly, we have 9 over X is equal to X over 30. So X squared is equal to 270. So when you want to take the square root of both sides of that, you would simplify. The biggest perfect square that goes into 270 is 9. 9 times 30. There's no perfect square in 30, right? 1, 4, 9, 16, 25, 36. None of those divide evenly into 30, so the square root of 9 is 3. And the square root of 30 we're going to leave alone. Okay, like I said, the most important part of understanding what a geometric mean is knowing how to solve that, that piece with an X squared. So we're going to talk about similar right triangles. Earlier in this unit, we talked about the triangle angle bisector theorem, where we had a problem that looked like this. And we had a side, we had a split side, and then we had another side of the whole triangle. And what we learned is whenever you have an angle bisector like this, it splits that opposite side into two proportional pieces so that the side of the triangle divided by the split side is equal to the other side of the triangle divided by the rest of the split side. Now, what's really important is because these two pictures look very similar, but the difference is that this is a right angle. And so when you split a right triangle with an altitude, CD, CD is an altitude, and when you drop that altitude, it's going to break that right triangle into two smaller right triangles. And all three of those triangles are proportional. Now, the way that I teach this is different than the way the book teaches it. we use what's called the box method, and it's simply called the box method because we use a box to organize our data. And notice on the table we have small triangle, medium triangle, large triangle. And each triangle has a short leg, a long leg, and a hypotenuse. So in order to find the short leg, we're going to start here with our hypotenuse, and we're going to find our smallest piece. So what that means is that that's the smallest piece of the entire picture, and so that is going to be your small triangle. Now, what you're going to do is you're going to take each side length and fill it in. So you look at your small triangle, that yellow triangle. The short leg of that small triangle is right here, and we don't know what it is. Remember, your 90-degree angle is there because it forms the linear pair, which means your long leg is x and your hypotenuse is 3. So now let's look at our medium-sized triangle. Here's our medium-sized triangle here in green. So we have our short leg x. We have our long leg, which we don't know, so we'll leave it blank, and we have our hypotenuse, which is 4. Now, notice that it went short leg, long leg, short leg, long leg. Okay, so notice that the short leg or the long leg of the small triangle is the short leg of the medium-sized triangle. You can see that also right here. Okay, then we need our large triangle. So we have our large triangle right here. So the short leg of our large triangle is 3, the long leg is 4, and the hypotenuse is 5. So now the good thing is we have enough information that we can set up a proportion, and we have a couple of options. So say you saw this first, we've got x over 3. That's medium over large. So it's the short leg of the medium and the large. Well, that means we've got to stick with medium and large. So the second column, this doesn't do me any good, but this one does. So what I would want to do is set up my proportion. X over 3 is equal to 4 over 5, because I'm going to use these 4 numbers. Notice how they're kind of already set up to use if you ignore that 4 in the middle. Now, you might ask, why didn't I use the other one? Well, no particular reason. I could have used x over 4. If I used x over 4, that's small and large. I have to continue to use small and large, and so in that case, I would have to do 3 and 5. Well, if we set that up, x over 4 is equal to 3 over 5. Notice, when you cross multiply either one of those, you end up with x is equal to 12 over 5, which is 2.4. So that means x is 2.4. From there, if I wanted to find the rest of the pieces, I could use Pythagorean theorem. I could also use, I could continue to use proportions. So let's try another one. Let's look at this one. So we need our small triangle. We start there. It's just my habit. Short leg, we don't know. There's your short leg. We do know our long leg of our pink triangle is x. And then we've got our hypotenuse, which is 5. Now we go to our medium-sized triangle. We've got our medium-sized triangle right here. Our short leg is x, our long leg we don't know, and our hypotenuse is 12. And then our big triangle is 5 for short leg, 12 for long leg, and 13 for the hypotenuse. Now, one of the things I wanted to point out, because this might help you to organize, is notice that the first row and the first column match. That's because everything from the small triangle, every side of the small triangle provides the short side for the other 2 triangles. So the long side of the long leg of the small triangle is the short leg of the medium. The hypotenuse of the small triangle is the short leg of the large triangle. So the small triangle is feeding everybody their short leg. And so it helps to kind of organize, to notice how your stuff is organized, because then it helps you set up the table a little bit quicker. Notice your middle column and your middle row are the same. And then notice that your last column and your last row are the same. Okay? So we filled in what we could. I see I have this set, medium, large, medium, large. That's just the one I picked. I had options. X over 5 is equal to 12 over 13. And so you get 60 divided by 13, which is 4.62. So x is equal to 4.62. That's this piece right here. Then I could use Pythagorean theorem or other proportions to find the the answer. Now it said one decimal place. It should technically be 4.6, okay, to 1 decimal place. Well, let's try another one. You can always put me on pause and try one yourself and see if you can make it work. Here's your small triangle. We put 4 on our short leg. We don't know our long leg. We have our hypotenuse. I don't know the short leg of my medium-sized triangle, but I do notice I have 15 on the hypotenuse and 4. That gives me 11. And I just fill in right now. I'm not worried about what I'm going to do with it or what direction I'm going to go. I just fill in everything I know. Then that's all I know about my medium-sized triangle. And then my large triangle, I have my short leg is Y, my long leg, I don't know, and my hypotenuse is 15. So it's easy to see right here how you're going to set it up. This is a geometric mean problem. 4 over Y is equal to Y over 15. And so when you cross multiply those, I want exact answers, no decimals. I get Y squared is equal to 60. If I take the square root of both sides, then Y squared, the square root of Y squared is Y. The square root of 60, we want to simplify that. The biggest perfect square that goes into 60 is 4, and it goes in 15 times. So the square root of 4 is 2. The square root of 15 is not exact, and so we'll leave it 2 root 15. And so my final answer for Y is 2 root 15. So on number 4, we want to find X, Y, and Z. So let's start filling in our chart. I have my short leg of the small is 9, long leg is X, hypotenuse is 15. I'm going to take that first row and copy it down into my first column. Then I need the long leg of my medium triangle, that's Z. Okay, again, it's short leg, long leg, if that helps you keep up with it, right? Short, long, short, long. Sometimes it's hard to see, especially that medium-sized triangle because it's usually turned upside down. And then the hypotenuse is Y. And then we have our large triangle. Again, we've got to go over here and get it off of our small triangle so I know that it's 15. Also, we know that our middle row matches our middle column, and our last column and last row, we need the hypotenuse. Now, this one's a little tricky because we don't know what it is, but we do have some information that we can put together. In the other times, there was nothing I could do, and so we just left it blank. But I can do something, and so it is important too. 9 plus Z. So if you're working along and you're accustomed to right now working with proportions, you'll start trying to do these with proportions, which is totally fine. But if you try to find X, either one of those, there is no combination where you don't introduce another variable. I mean, like if you look at these 4, it introduces a Z. If you look at these, it has a Z and a Y. And so you can't do those. So we can't do X. Same problem when we try to do Y, try to solve for Y, is we have too many variables. It introduces too many. So if we keep going, we'll see here I notice 9 plus Z. I can't use Y, but I could use 15. And I can't, again, use this Y, but I can use this 15, and I can use that 9. So that makes it good because then I have one variable, and I can set up my equation to solve. So cross multiply, you get 81 plus 9Z is equal to 225. 9Z is equal to 100 and... Oh, sorry, thought I had it done already. 225, 144 divided by 9, and you get that Z is 16. Okay, if Z is 16, go in and fill it in. Like after you find it, go in and fill it in because you're going to need it. We don't like to use what we already have, or what we just found, but sometimes you have to. That way, you don't want to use it if you don't have to because you might have made a mistake, but we didn't, and we have to. We have to use that Z to get what we need. So now that you have Z, see, now it creates this right here. So we can do 9 over X is equal to X over 16. So 9 times 16 is 144. x squared, again, this is that geometric mean setup, is 144, square root of both sides. 144 is a perfect square, so x is 12. So now I know that x is 12. That's 12 and that's 12. And now I can find y, and there are any number of ways you can find y. One way that I see just right here set up for me that makes it easy is 12 over 16 is equal to 15 over y. And we get that y is 20. Now, you do have a couple of options. Maybe you didn't see it, or maybe you did. One of the things that I recognized when you look at this is, you see this triangle right here? It's a right triangle, and you have two sides of that right triangle. So you could have gone and found that x was 12. It's a 3, 4, 5 triangle. You could have used Pythagorean theorem. X squared plus 9 squared is equal to 15 squared. Or if you recognize this is 5 times 3, this is 3 times 3, that means x has to be 3 times 4. Then you could have gotten it that way. So you could have found x using Pythagorean theorem, and then you could have worked your way around. Now, after you found other pieces, you could have also used the Pythagorean theorem to find some of those too. So don't forget, Pythagorean theorem is always an option when you are dealing with right triangles. So lastly, a good example of when this is a useful method of solving a problem is if you're in the gym and you want to know how tall the wall is. You can't just run a measuring tape necessarily up the wall. You don't have shadows to be able to measure your height and your shadow and the shadow of the wall to be able to use similar triangles that way. But what you can do is you can take a piece of paper. We've got this piece of paper right here because it's at a right angle. And if you hold it up to your eyes and you eyeball it up, you can set your sights so that you can see the top of the wall on the top of the paper, and then the bottom of the wall on the bottom of the paper. Then what you would do is you'd have somebody measure your distance from the wall, which is 8.5 feet, and then the height of your eyeballs. You need that. And then what you can do is you can find W. The reason you can do that is we've got our small triangle. It has a short leg of 5 and a long leg of 8.5. We don't have the hypotenuse. Then we also have the short leg of the medium triangle is 8.5, and the long leg is W. Now, right here, I have enough to find out what I need, so I don't need to worry about anything else. So I have 5 over 8.5 is equal to 8.5 over W. When you cross multiply and solve that, you get that W is 14.45 feet. Now be careful, because your tendency is going to be to want to answer that, and that is certainly going to be a possible answer choice if you were looking at a problem like this. What you have to recognize is that I asked for the height of the wall. And so you have to add that 5 feet to your eyeballs back in, which means that the height of the wall is 19.45 feet. So the purpose of the box is not magical. It is just a way to organize. Otherwise, you have to use these similarity statements and keep up with AB over AC is equal to BC over CD. And you can see that there are so many different combinations. Some of you can see it. It's like short and long, short and long. But I find it's just easier to set up that table. So anytime you see a problem that looks like this, that has the right angle, it has to have that right angle at the top. If it doesn't have the right angle, this box doesn't work. But it will help you to organize your data so that you can find